soar, use your own AI, we'll explore. Help the future hand in hand in this tech-driven wonderland.
Okay, well, welcome to a special office hours. We actually are in person here in San Francisco with Alex, and so we're going to do a whiteboard deep dive. We're going to improvise, so feel free to kind of enjoy the show. Hopefully it's educational. We'll try to go a little bit deeper than usual into some of the topics. But yeah, welcome, and let's start. So I tweeted this few different hypotheses that I think will be pushing the envelope on research in AI. And so we wanted to kind of launch off that and also discuss some of the other topics we're working on. So maybe to start, so one of the kind of core challenges with the current models is that because they're trained on massive amounts of tokens, it takes extremely kind of lots of compute to actually produce a model and train it. And obviously, the model itself is not trained in the most optimal way, right? It's getting random pieces of content, like it's usually chunked kind of in the middle of a document sometimes.
Like in the second epoch, it sees, well, not epoch, but early on, it sees like a proof of Riemann hypothesis.
Yeah, like something about medical stuff, some article about royalty.
And then closer to the end, like it's being fed something from 4chan, and it's not contributing as much into.
Yeah. So kind of there's like few of the research topics called curriculum learning and active learning around how to prioritize which data you feed to the model. So wanted to discuss that, and kind of Alex been thinking about it for a while.
Yeah, I like this visualization of that, which is by no means scientific. But imagine that you plot your, you have some sort of omniscient oracle who looks at your entire data set, and for every document, it assigns a value of how smart that document is, right? So like, and
how much intelligence it requires.
Right, and then we will assume that smartness, because the data set is sorted, right? If you look at, and this is your data set as you're feeding it into the model, right? So this is time. And assuming the data set is somewhat uniformly shuffled, if you look at like distribution of smartness during different times, it will be more or less the same, right? So like some very smart data on the very top, slightly less smart data, and this is like ready.
The rest of internet.
Yes. Yeah. Now, the way I like to think about it, especially if I find the eraser, is let's say that exactly half of the data is only useful when it comes to learning grammar of English, and has no other usefulness to it. And then half of the rest, so this is 50%, not very useful, 25%, slightly more useful, then 12%, even more useful. And now I will exaggerate it significantly, but it will sort of deliver the point. Imagine that in order to even start grasping usefulness of this half, you need to go through half of this data set, or like in general.
Well, I think in maybe two ways to specify, right? So when you're training these models, like generative pre-training, right? What it does, it's trying to predict the next token. And so in the beginning, like the basic grammar rules is enough to like reduce the loss, right?
Yeah.
So like if you understand at least how English sentences are constructed and like basic vocabulary, that like an article goes before a word, etc., right? That already reduces loss, right? But obviously, as you train more and on more complicated things, you need to actually start reasoning and making inferences and remembering facts.
Right. So in this case, let's say that this is like that this 25% start involving basic reasoning, and let's say that you need so that will be an exaggeration of the actual percentage. But let's say you need to this 50% of the lowest level data set consumed before you even start comprehending reasoning, right? So in this case, this part of the data is only useful here, and up to this point, you were only using it to learn grammar, which is not the most efficient way of using this particular data. Like it would have been much better to swap them, right? So like to move this block of data, which is only useful from perspective of learning grammar here, and this that gives you reasoning here, right? In which case you will double your effective
Learning from
learning
from
from
a
this
text
data
that
set,
has,
right? And then here you have something even more smart, right? But then it takes you half of this time to start comprehending it, and so here you only use 1/8 of this data set, and then you only use 1/16. But the actual coefficient is not 50%, right? It's less than that. But the point here is that somewhere on top you have, like, let's say you want the model to be good at reasoning about general relativity, differential geometry, tensor calculus, all those things, right? And let's say that this is like level 7 of this diagram, and so you do have, people do
talk about it
on the internet, right? There are textbooks, people talk about it on Reddit, in specialized subreddits, people talk about it on like physics.stack exchange, and this is all like in here, but you only use like 1/256 of this data set, and with each consecutive level, you use exponentially less and less of the data usefully, right? And if you were able, if you had those labels from the Oracle and you were able to reshuffle your data set, you would be able to be, like you wouldn't even need new data which doesn't exist yet. You would just use whatever you have there efficiently.
Yeah, and so as a humans, right, we're also not getting thrown, an article of theoretical physics, an article about, linear equations, and an article about how, I don't know, how different species are related to each other before we learned,
how to read,
yeah, and kind of maybe basic math. And so the idea is like, how do we design a system? And the thing about this is actually this doesn't need to modify any of the architecture of the model. This is just a training procedure that needs to be modified. And so the question is how to get that oracle, right, that given a document returns, well, you called it smartness, but non-scientific smartness score. Right, and the thing is, like, you probably don't need this to be, 100%. Like, obviously, it's really hard. But if you get a reasonable correlation, you can use this. And so one interesting point is that if you take any of the document anywhere and you take existing model, right? Let's say we take Llama 3, and we run that model on this document. If the document doesn't require kind of the lower it is on this level, the more that that model already is good at predicting it. That's kind of what we train them to do, right? And so you actually can use the loss of let's say Llama, which it gives you a predictive loss if you score the document, as a way to approximate this. Now, it's indeed not always going to be like completely correct, but
yeah, because complete garbage will have a pretty high loss.
Yeah, and so there are a few things that you need to kind of correct for, right? So there's if you look at any document, and this is kind of for those who are actually training this or looking at these models, you can imagine, let's say it's a news article, right? And there is like a title, And then there's an author. And then there's like something. And then there's an ad probably. And there's something else, right? And so the reality is, even in a general article, there's like already a bunch of stuff that actually almost impossible to predict. Like if I give you this title and ask you to predict an author, like even with all the intelligence, it'll be really hard. I mean, maybe if you learn who works where, in which media company and which topics they cover, but like generally, there's already parts of the document that you ideally want to kind of ignore. So there's another part, and again, similarly, if there's a document that has complete garbage, right, which sadly internet is full of, but literally just spam of like, comma, 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 like some words repeated, somebody like optimizing for SEO, there's like a bunch of just, random words. Like you want to figure out how to filter those documents anyway, right? This is definitely not helpful for anything. As well as on a document level, there's parts that are completely unpredictable. And again, the model will output. So there's a kind of, if you look at this loss and the correlation with smartness, they're going to be kind of a distribution as well, right? So loss, smartness. So really high loss, probably low smartness. And so, I mean, I haven't plotted this, but yeah.
You know the meme?
Yeah. Except this is spam, but yes. Yeah, so anyway, so there's kind of some procedure we can use here. Now, the other way, which is more active, right? So this is kind of, you score this data ahead of time. Now, the problem is this is also computationally really expensive because you literally need to run your model over the whole data set, which is exactly what the training is. But you need to do it once, presumably, to sort this. Now you can train every model using that function, right? Now, there's an interesting option, which is, can you do it actively, right? So as you're training a model, right? So right now, let's say you have a model, you are, feeding some data. You compute the loss, and you kind of update the model from this. And so right now, kind of generally, I mean, this is another hypothesis. So the idea of active learning is you, instead of kind of feeding just random pieces of data, you actually try to find, like you kind of ask the model what would be the most ambiguous for it, right? So in a way you can say like, oh, well, if loss is, let's say 3, what would be the inputs? And you sample the inputs from this, right? And then you kind of, now, generally active learning is used with human feedback, right? And so for pre-training, it may be not very effective because like ideally you have a question, for example, question answering system or something similar, and you are trying to find, what questions to add to, like what pairs of question answers to add to find to improve the model. But indeed, it's a bit hard. Now, can you do that if you have like this big data set, right? So lots of documents. Pretty much, can you cheaply find something in it that is, the most promising for you to update? And so you can have like a smaller model. That's one option. You can have, if you're training. So right now, this is, let's say 15 trillion tokens, which is a lot. If you're training on a smaller subset, let's say you just take Wikipedia, for example, only, right, which is 2.5 billion tokens. So yeah, so right now it's trained on 7,500 Wikipedia size of content. So you can train multiple times on it, right? So you can actually sort data, from a previous epoch based on how your model scored to feed it in an order that's more useful for it to update. Because the other thing is, these models right now need to like backprop 1,000 times something to actually memorize it effectively.
So, like a simple idea would be, instead of grabbing a random document, you grab random 10, compute the loss and train on the 5 that have the median, yeah. So that presumably drops the stuff that you understand very well, which might potentially bring you back, and removes the stuff which is either spam or something beyond your comprehension yet. So the only problem now is that, so early on, that would make sense, right? Like if you hear, like early on, you grab some documents, the spam, which we don't even, like let's say there's also spam here, will have high loss, something you don't understand will have high loss. You will be picking these ones. What you want to happen is that later down the road, you kind of want to be able to find out, because you were running into them, right? Like as you were moving along, you were running into smart data. So it would be nice to somehow remember,
fetch it later.
Yes.
This was something I didn't know how to do before, minus spam.
Yeah. But hopefully you remove the spam ahead of time, right? So spam can be potentially detected
with like
by entropy is too high or something like this.
Yeah. I mean, the one option is you use like a downsample model, like 1B model, for example, to score data as well, pre-score data, find things that are like complete, not even grammar predictable, and then filter out that. Okay. Sounds like something needs to be done. Yeah. And then the other interesting thing, I mean, this is just like a thought, that when you're training right now, you're applying loss kind of evenly across the whole document, right? And so there are places which are like either unpredictable or really hard to predict, like a first token in the document, right? Like, tell me how this document going to start from, a start of a document token. It's really hard. So in a way, you want to kind of also update a little bit how the loss is propagated based on, in general, how predictable can this be in a training procedure.
I think another interesting, completely tangential to that idea here is that, like obviously for the lower levels of smartness, you have to mine internet. But like, if you go to Llama today and you ask her something about CUDA, it will give you something pretty meaningful, right? So like it's grasping at least some concepts of CUDA, but naturally the amount of data in the internet for CUDA was much smaller, right? So the higher the level, the more tractable it becomes to just, grab humans and annotate data from scratch, right? So instead of trying to find a way to automatically identify smart data, you can create smart data and put it at the end, or I guess, I don't know, fine tune on it.
Yeah. I guess, I mean, relevant to this question is we want the model to understand how to read this, how to reason about it. They don't always need it to remember all of this, right? Because the other part right now with this model is we're trying to actually get them to remember every single fact and, thing that's happening on internet, because that would be the low, then at the, training time, it will get the lowest loss on predicting next token. And so the interesting question there is like, how can we modify the training procedure in such a way that it doesn't need to remember, it can actually use something in a context to, for example, better predict the documents. And so one idea that I had actually is, as starting to train on documents in kind of these places, is to find relevant information that may be at either previous levels of smartness, but that contains kind of some information, and putting that in a context before predicting, right? So let's say, I mean, you're reading a Wikipedia article about, linear equations. Maybe you want to put in, well, maybe linear equations is, I don't know, some fact, like you're generating like a news article about NVIDIA. And so you want to put in maybe like NVIDIA Wikipedia article and something else.
So you want some retrieval at training time.
At training time, yes. Because the big benefit of these models is that they're, can use the context to retrieve information, right? And you just only, backprop loss here, and use this more just for context.
Yep. Well, shall we talk about how easy it is to train model from scratch today in 2024?
No, you can. Oh.
Okay. So there's another somewhat fundamental area of thinking, which has nothing to do with the science of training models and more about the current state of the world. Let me use my favorite analogy, which is let's say that today in 2024, I want to create a document. Yeah, like Illia and I are preparing for this office hours, which we absolutely did not, as you can see. But let's say we were, put more effort into it and actually try to prepare. Then we would create a document, right? And we would have multiple ways of putting it together, right? One of them would be, and that's likely what we would have actually done, is to use Google Docs. However, I might have ahead of time say, well, that document, I would prefer to preserve it for posterity. Like, when I'm 90 years old, I would like to look at that document preparing for the office hours. And Google Docs is not the way. I mean, I can probably save it, but right. And so I would open up my copy of Microsoft Word and prepare it in the Microsoft Word. Or I can say, well, I can prepare it in Microsoft Word, but then by the time I'm 90, Microsoft could be gone. Microsoft Word is, not supported anymore. And nobody will be there to pick up the torch because Microsoft Word is not open source, right? So instead, I would open LibreOffice.
That escalated quickly.
Right. And so now let's see how much of open source each of them is, right? So Google Docs is not open source. And also, I have no ownership of data of anything that is stored on Google Docs, right? So no ownership. Data belongs to, and no ability to tinker with the Google Doc binary. Like, if Google tomorrow says, now, you want these buttons to be swapped because someone needed to get a promotion at Google, I can do nothing about it, right? Microsoft Word, not open source, for sure, but I do get to have a binary, right? I have a binary of which I can make no sense at all, but I have it locally, right? So if tomorrow Microsoft Word says, hey, instead of toolbar, we will have a ribbon, which they did to us, I can say, well, I'm not going to use your ribbon. I will use the old Microsoft Word, right? So, well, I guess it's separate from ownership of data, right? Like I can tinker with it, no tinkering.
Well, so there's no tinkering, and there's like
limited tinkering, right?
Well, it's more like,
but
you're not forced to upgrade. Yeah.
But I guess also importantly, I have ownership of data. Like, nobody's looking into my documents I'm editing locally. I actually don't know if Microsoft Word is. That's the time have changed. Yeah, tinkering. Okay, and LibreOffice, it's open source. I mean, it's as open source as it gets. I can download the code. I can, if I don't like something about it, I can change it. I own my data. I can tinker as much as I want. So even though in Microsoft Word, I can tinker a little bit with the binary, I can write a plugin for Microsoft Word. I don't know if I can. I own my data. Nobody would ever say Microsoft Word is open source, right? So now if I don't know how far this goes, but let's say there's more space. If we compare it to the state of the artificial intelligence today, Google Docs would be OpenAI or like Anthropic, anything that goes through the API, right? Like if I use OpenAI, like a good example with OpenAI is when they introduced this button that says, we're not going to save your history, and then in my particular instantiation, one day it just flipped back because they changed the control, and the new control by default was again saving my history, and saving history means training on my data, right? So like OpenAI, I have no control over how my data is being used. At best, I can they can promise not to use my data, and I can trust them. And then Llama and Mistral would not be in the last row for sure, right? Because in reality, with Llama and Mistral, what we get is we get this binary that we cannot make much sense of, right? So Llama would be more like Microsoft Word, right? So I own my data. Everything I do locally, more like Stable Diffusion. If I locally do inference, I know for sure that data doesn't go anywhere. It stays with me. I can do some limited tinkering. I can fine-tune, do LoRa, but it's not open source, right? Even though they called open source models, they are not open source because I cannot, like if I want to change something in them fundamentally, that is not something I can do. Training loop is not open source.
Well,
right?
and you don't actually know what went into it.
Yeah, we don't know the data
set.
that went in. We don't know the training loop, right? So like if I say, well, I like Llama, but I wanted to understand images now. So how about I change the training distribution a little bit, right? Or like apply more filtering. None of that is possible, right? And like
here, and also the flip side of this is this paper on sleeper agents, where you pretty much train the model to have a specific behavior at a specific instance, and that doesn't show up at any eval set or persists over fine tuning.
Yeah.
And so like there can be like things that are when the condition triggers, it installs, for example, a npm package in your Python when it's get called that has a malicious, for example, code.
Yeah. Okay, and so now, well, I haven't been following the space very closely recently, but the only model I knew as of like a month ago was Olmo, which is Allen's Institute of Technology, right? Yeah. So that one is, you can reproduce it, right? You can download everything, and the problem is that here's the problem: that as the industry goes forward, we need to make sure that we have open source models that are competitive with the state of the art, right? So clearly you can be in three different regimes. One is that where even open weight, let's call them open weight, even open weight models are not competitive with state of the art, right? This is complete dystopia that effectively means that, and here I make an assumption that AI will actually drastically change the way we experience the internet and will become, the fundamental part of our interactions with it. Then we at the mercy of two companies.
We always go through their gateway.
Yeah, and we always go through their gateway, which has been the case in multiple other areas of our lives, social networks, search, etc. And that is not great. Second one is open weight models are competitive. This is strictly better, right? So then, at least at the point of time when open weights models are better, there is a possibility for competing products. The problem with open weight models is that there is no it is not future-proof, right? So these guys, they will be innovating, right? And in the moment we have open weight models, and in the moment we have those entities who publish them aligned in terms of incentives with the big guys, they're aligned in terms of incentives with the world to publish those models for various reasons. Like, for example, for some of them, the reason could be that they get attention today because attention is important. For some others, I can only guess motives for Facebook, but I think Facebook has been known for open sourcing stuff because then people tinker with it and Facebook gets it. Like if there is Llama and GPT and Llama is open source, then Facebook gets a whole world working on their stuff, right? They get VLLM and whatnot for free effectively. And that's like a very nice synergy, right? People get open weight models, Facebook gets development on it. But it's not future-proof because if at some point incentives change, right? So suddenly, like hypothetical, I don't want to name any names, but like any company that was interested because of the attention, the moment attention is not as valuable anymore, and they want to start generating profits, the license change. Don't know if it ever happened yet. Right, but if you have an open source model, it is future-proof, right? So let's say for the company, let's say Allen's Institute of Technology says tomorrow, well, we don't want to work on Olmo anymore. It's not anymore, meaningful for us. Anyone can pick up from where they've left and train a new model, right? The next generation. So it's very important that there is a open source model.
Well, I think
competitive.
It's it's not on itself future-proof, right? Because the future-proofness here comes from the flywheel of, like they have a model, they put it into a product that generates revenue, that they put back into data, compute, people. This is product, which then improves the model.
Right. So I think an important, there was a couple of steps in my head that I forgot to put on the whiteboard. But in this case, for the product to exist, right? So we have the model, right? Let's say it's Llama, and then we want the product, and let's say the product would be even just like a ChatGPT alternative, right? So for a company to truly commit into making it to be a very appealing competitor, that company needs to be certain that they will not die out if the model they depend on gets discontinued, and suddenly, once ChatGPT switches, to GPT-5, they will be left behind because there is no GPT-5 for them to switch onto, and there as a company, right? So like, if you want to build a future-proof company, it's much better to know that the infrastructure on top of which you're building will be evolving.
Yeah, but ideally, what you want is kind of this system to exist in open source, where more people, data, and compute are being kind of gathered to build a better model that then not just one, but many products are built around, which then fund development of this.
Yep.
Hence the economy of blockchain. Like you need some kind of platform that is encouraged by the fact that more people are building on top of it versus competing kind of product that they pretty much trying to eat everybody else, which is generally how any single for-profit company needs to exist.
Yep. At which point, of course, it's very desirable for normal people to be able to interact with the blockchain.
You were going somewhere?
No, more or less
in the training loop.
No, no. I think that's more or less the stage I wanted to build up.
Well, I think the question, we kind of mentioned that, I think, last office hours around like training loop. Because right now, indeed, I think there's this, and then there is a Megatron, which is from NVIDIA. And I don't know if there's anything else. And all of them obviously require data center level of compute. You can start with obviously smaller setup, but if you want to train 70B model, which seems reasonably powerful. This is what 3 months of.
So the original Llama paper reported, I think, something like 29 days on 248 A100s.
Mm-hmm.
However, my limited knowledge of those training loops suggests that was an extremely optimized code, which not everybody has access to.
Yeah.
So I think for more realistic,
the
code,
question
that would
is,
be like around a couple of months.
Yeah. The question is, can we, in open source, right? The benefit we have is that we can have more people actually looking at it and optimizing it.
Yeah.
And so, again, we briefly discussed it, but it was, you can imagine like a training loop that is open source. You have a kind of few, in a way, plugins, right, on the model, on data sampling procedure. Maybe you have the trainer / optimizer that are kind of easy to plug in. And so the biggest benefit is right now, as is, the researchers who are like, hey, I have this idea, right? We just discussed something. I can code it up, and ship it tomorrow. I just don't have this level of compute.
Yeah.
And so ideally, we would have a place where they can come in and say like, hey, here is a pretty much pull request with some modifications. train it on maybe like 1B first. If it shows improvements or shows interesting results, then scale it to, let's say, 7B to 70B, right? So and then you kind of have behind this you have few clusters of compute that are
so there is like a
it's like an open AI research lab where actually people can come in and suggest.
No, it's like open end of token AI, not open AI as a token.
Token. You need a better tokenizer. Yeah.
What is so? This is what is it? It's like 2K per hour, right? Which is for 1 month. Where is my calculator?
I think it's 6 million.
You can talk about some other thought in the meantime.
Yeah. So I mean, this is kind of something we've been thinking about, like to build in open source. All right. Yeah. So you can imagine 1B you can probably train for way cheaper.
Mm-hmm. Well, let's just say it scales linearly for simplicity. Right. That should be easy to divide by 70. It's like
20K.
0.2. Yeah, 0.02, 20K. Yeah, that becomes tractable.
Yeah. I mean, you probably start with like even smaller, but yeah.
Right.
I think it should be cheaper right now. I think 7B you can train with like 128 for a week or something. So anyway. Yeah, so there's like in a way there's like a research grant to someone, and then you kind of experiment with a few of those, and then explore probably a combination of this for a bigger model. Yeah, so as a community, we should build this to truly be the home for user-owned and open source AI.
Yeah, sounds great.
All right. So that's solved, clearly. All right. Do we want to talk about symbolic stuff?
Sure. I mean, we don't have much probably to say about it. But I guess like a very short bit of trivia is that Illia and I, when we met, one of the things that we shared in common was that both of us, during our master's days, were trying to use symbolic AI for whatever. And so
for program synthesis.
Program synthesis, yes. Yeah. So both of us kind of dream about using it one day. But are we any closer to knowing how to do that? No. but like, do you want to draw your diagram with the user and the system?
You mean for the developer?
Yeah, for AI developer, but I think it applies to anything.
Yeah. So, well, maybe there's like few things, but specifically, I actually talked about this at town hall earlier. We're working on this thing we call the AI developer, right? So you can assume there's a person and they want to build some application, right? So there's an application here, and without loss of generality, we assume it's a Web3 application.
Yeah.
Right, which has some kind of smart contract, some kind of we call it middleware, and then some front end. And so we want an AI who will go from build I don't know, freelancer marketplace that will actually give you a full application. Now, if you imagine on this side, you actually have a human that is like, get this. I mean, they'll assume something, right? They can build a freelance application, but it's probably not the one that the user wanted, right? And so you first need kind of a process which, usually somebody like a product manager or the person themselves are engaged, which is actually write out exactly what they want to be built, right? So we call this a specification. And so the reality is, though, there's a lot of detail that the specification should go into to actually fully describe this. And so you actually have a kind of iterative process where, as the user, hey, build a freelancer marketplace. Let's imagine there's, we call it AIPM, product manager, who writes a specification for you. You're like, well, actually, that's not exactly what I wanted. I actually want maybe to, I want people to have NFT badges for every time they complete their task, right? And so you kind of update and add features and maybe modify the user flows. And so at some point, when you're content with the specification, you then say, OK, let's build it. And so that gets shipped to proverbial AI developer, who is then writes the code. Now,
potentially still coming back to you to update the spec as it goes.
Yeah, it potentially either comes back to you and you can update the spec, right? So in a way, you can almost model it as if you had like a dev team behind the chat and you in the group chat with them. And you had two outputs for them. One is documentation of the project, and the other one is the app itself. And you can kind of iterate with them on this. That's why there's potentially also like AI designer who helps with the front end, etc. So that's kind of we're building this system out. We're going to be opening up this part to play around for the community in a bit. So you can actually like write out your ideas, see the specification, iterate on it, and then we're gonna start leveraging already what we have, but also people to develop this and kind of iterate on and to see how best train the developer to do this. But one of the biggest issues with all this, and kind of generally with the current state of LLM writing code, is that they're not very good at it at a sufficient detail of reasoning and logic.
Not very rigorous.
Very rigorous, yeah. And so with smart contracts, it's especially important that you are very rigorous and you don't lose people's money, assets, and so you have set of conditions that you want. Right now, the way it's done is it's sent to an auditor, which is another person who reviews the code, finds one issues, and then kind of developers iterate on it. But that is, usually a very cumbersome process, and auditors also need to know the specification.
And they also make mistakes.
And they also make mistakes.
Like if you have an AI auditor here.
Yeah.
But even human auditors, they make mistakes.
Yeah, they miss things, right? How many smart contracts got hacked which had an audit? So the question is, can we have some form of guarantee that this smart contract is indeed correct up to a specification, plus some set of conditions and variants around not losing money, not changing ownership of the assets without the originating user confirming it, etc.
Yeah. So what would be interesting here is if imagine that there is a high-level language on which, or rather, I actually don't know if there's any formal proof systems for stability, but they do exist for Rust, for example, right? So people for many years now, people have had ways of formally proving that the code does something you expect from it. But you can probably go even one level higher and say, so now there's a specification language, which is an actual symbolic language, which can be, reasoned about using some sort of proof system, right? And so when the user comes into the system and says, I want to build a freelance marketplace, that is natural language. So there's an LLM, but the LLM, the output of the LLM is not in the language space as it is today, but instead it uses this symbolic, let's call it domain-specific language, in which it builds some sort of understanding of what the user wants. And for this system, for this DSL, we want two properties. Property number one is that it can be converted to a smart contract / middleware like without using any leaky LLMs, right? So like there's an actual routine that converts the DSL into the smart contract and middleware. And similarly, there's a way to convert it to language which conveys exactly what the DSL is, right? So like ideally what you want to happen is that you go to the EIPM builds this DSL, and then it communicates back to you saying, on the high level, this is what I think you want. And then the user can say, well, either yes, that's exactly what I want, or no, that's not quite what I want. But once they're done, what the EIPM has is something that user signed off as what they want, which can be directly translated into code. The problem here is that you want it to be sufficiently low level to be able to convert to the smart contract / middleware, but sufficiently high level to communicate back to the user. So potentially this like single step is not quite possible. Maybe it requires.
Well, I think the more problematic statement is that there's a specification stage, right, where say like again, I'll just use some conditions, right? You don't like for any token, for every token, right? The ownership of a token kind of I don't know. I'll mess up right now the formal specification, but the owner of a token, doesn't change after transaction unless there is a like clear, clear intent by the owner, right? So that would be, for example, a very specific condition that you want to insert that actually user may not even like explicitly state.
Yeah.
But the solution to this, right, is that in every function call, right, in Rust, like there is something that needs to be happening to satisfy this. So there is this kind of separation between, in a way, specification, right, and the solution.
So there's an implicit set of assumptions, which the user doesn't even think about.
Yeah, which ideally we have just because they're in the system overall, right?
Yeah.
Or maybe user does want this to be different, right? Maybe like they run something that randomly changes owners every tick of a time, but like they need to specify that explicitly. So there is the step of going from, first of all, solving the specification with the solution, which ideally, indeed, the solution is also formal. So you can go to a actual code, and you can have a proof, right, that this formal solution is indeed satisfies all of the specifications, condition, and invariants.
Yeah. Right. I thought you were saying the problem is that the user will not even notice that.
Well, yeah, but those can be added like almost implicitly to the specification, right? Presumably our EIPM is very much like crypto aware, crypto native degen, and so they know this, right? But we need this kind of system, and so there is actually a really interesting paper of a geometry which is kind of in this direction. I don't know if you want to describe it.
Right. Okay. So I think alpha geometry is the most interesting paper today, which. So if we move like one level higher, the general property we desire from the system is that the system, when it does reasoning in the symbolic space where it cannot mess up, because in the language space, models mess up and people mess up. And as of today, we have actually no evidence that it is possible to reason in a language space without messing up. But we do know that it's possible to do it in symbolic space. But of course, symbolic space, it blows up because the search space is huge. So ideally, what you want is symbolic space for reasoning and large language model as an intuition. And alpha geometry is very close to that. They say, well, it happens to be the case that for geometry, the symbolic, the DSL is relatively limited. I think it's still massive. I think the amount of effort that they put into creating it was, it's hard to estimate, but if you watch the video, they scroll through the definition of it, and it doesn't end scrolling while they show it. But it is tractable, right? They managed to describe it, and they also limit significantly what intuition means, right? It doesn't even happen in the language space; it still happens in the symbolic space. But they effectively, I don't even think it's still can be called intuition. Instead, they just say that every now and then, when you solve a problem, you need to what they call pull the rabbit out of a hat, and say, and now I'm going to introduce this concept which comes out of nowhere. But then once it is present, the problem, the solution becomes tractable.
Well, I mean, same as competitive programming, right? Like you have a problem,
yeah,
right? And like the solution is you use black skulls or whatever, or something.
Yeah,
like a.
I think in competitive programming, quite frequently the rabbit is the whole solution.
Well, right? it's like it's some algorithm that if you apply it, then everything else kind of fits into place.
Right.
Right.
And so if we go back either to competitive programming or even to AIPM, right? So effectively, let's use the AIPM as an example because we already introduced it, right? So you have the user. I will draw the same as you did, and then you have code, right? And so as I said, I want, and then we want the user to communicate to the system, to the AIPM, and the AIPM. Well, I cannot. Okay, the user.
Sadly, after COVID, we are not used to the whiteboards, meaning we are used to Mirror, where you can just zoom in.
Yeah, and like drop arrows precisely, right?
Yeah.
And so you communicate to this AIPM, which hears language, and back also goes language. But internally, AIPM, like if you zoom in into their sort of head, they have this DSL, right? So naturally, there is a DSL such that any code can be expressed through it. Like there's a I don't remember the name, but there is a system built on top of Rust that allows you to provide formal guarantees for every function, right? So we know that
Rust core itself is actually formally verified.
Right, but I'm saying like you can annotate functions saying like this function will have this invariant, and then there's a compiler that will verify it for you, right? However, it's so low level that any meaningful, like if you convert it back to natural language, it will not convey anything to the user, right? At the same time, for any particular idea, right? So let's say I want to build an order book. There's a DSL which has exactly one operation which says build an order book, right? Which can be converted back to language and to code, right? But it's not very generalizable, right? And so you can like imagine how generalizable it is and how understood it can be by a user, right? And so here's our example of the order book, right? And here's the low-level language. And so the question is how this looks like and whether there is, and so like let's say there's like a space of sufficiently generalizable and sufficiently understood by the user, like it goes somewhere here, right? And like the question is, does this curve touch it, or does it go entirely below? And if it does go entirely below, can we split it into multiple steps or introduce some other? This is not supposed to be here. Or can we introduce, some other components to the system that will make it look more like this? Yeah, but hopefully.
But I mean, this is what we're saying. If the spec already is convertible to code 1-to-1.
Yeah. So exactly. So like, so this is for the. We're saying yes. What we get the DSLs, and for every level of generalizability, we have an oracle which has what is the best DSL in terms of being understood by the human.
But I think the problem here is that you like the what's understood by a human is the problem specification. What code needs to contain is the solution, right? So there is a step of like solving.
Yeah.
Which I think that's what I mean. You still have the same like for the description of the problem statement. Like how generalizable is that problem statement? How easy it is to modify it, right? Because like it's not build an order book; it's build a specific order book that is in your mind, right? There's a very specific handling of all of the edge cases, versus if you modify even one thing, now you need like a completely different language. Versus like this point with code with like Rust annotations, it's already a solution, right? It doesn't actually have like a
Right. In my head, they're not quite separated. I think ideally you want to be in a situation where for problem statement you can go in the symbolic space to the solution.
I mean, I think they should be in the same language space, but I do think there's
which in alpha geometry was the case. The problem definition was in the same space as the solution.
But I think there's an expected, at least for me, there's an expected step of that the solution that is convertible to like this is one-to-one very explicitly.
Yeah. And
this actually requires like
and this is where you need symbolic reasoning with the intuition.
Yeah. Which like this is where you need to come up with this and then prove that it actually satisfies all the invariants.
Yeah.
So this is where like actually like solver coming. And I think like why this is important is because if you think of any code that is written, all of it is so far been written by people, and people have, I think like there's like 2-3 bugs per 10,000 lines of code, something like that.
That sounds extremely optimistic.
Okay. Maybe by 1,000 lines of code. So the chat, I mean, well-written code with lots of tests, etc.
Yeah.
And so the problem is like, there's millions and millions of lines of code right now in your, like you can have you have networking stack, you have operating system, and you have your browser, and then you have your applications, right? Assuming everything is just web apps. Like in all of this, right, starting with networking, there's vulnerabilities. And as the progress of AI actually goes forward, AI actually will be way better at finding bugs already in the code, kind of just because it's like a statistical problem and like the intuition problem versus doing this, versus like writing a correct code on itself, again, with LLMs right now. And so we're going to see more and more vulnerabilities being found and potentially exploited by the using LLM. That's one of the kind of the AI risk directions, right, that people are exploring. And so this is extremely important because in a way we need to rebuild the internet with this and cryptography and other pieces kind of from scratch to ensure we have kind of not breakable internet with AI.
So to give a little bit of a different perspective, right? Like Linux networking stack certainly has vulnerabilities. There's absolutely no way that many lines of code were written without vulnerabilities. And the way I see the security model of the networking stack is that a very smart person cannot find that vulnerability, right? Because a lot of very smart people looked at it and they didn't find them. However, the model can become much better than people at finding vulnerabilities way before it becomes like AGI or because that's a very narrow.
And can run the code, it can write tests, it can like simulate it. Like if somebody is really targeting that specific problem.
Like as an example of that, the models today are very good at writing code, right? They're still not applicable in many cases, but clearly, if you show the current model to a person like in 2022, in the early 2022, they would be mind blown, right? And so correspondingly, but in some other areas of something that we consider to be trivial, the models still mess up, right? So the same argument applies. Like they will become, maybe they already have become much better at breaking code than people, right? And finding a 0-day in the networking stack of Linux could be relatively disastrous,
colossal,
right, for the world, right? And so we either need to ensure that the good guys find them first and patch it, or I don't think we can in any way prevent the models from developing in that direction, or like alternative would be to just build something that is fully verifiable and just rewrite the whole networking stack, and preemptively deploy something that is provably correct.
Yeah, and I think in general, like from a kind of general safety approach, right, the whole point of like math is that, yeah, like if you can have a proof and it's logically sound, then there's no alternative way to kind of work around that. It doesn't matter how much more intelligence or compute you have.
Yeah.
Versus if you have anything outside of that, right, outside of like formal logic and kind of mathematical proof, potentially you can kind of brute force a way around it. Hence why, again, cryptography being one of the fundamental blocks as well of creating the system. I mean, right now it's used everywhere here as well. Right?
And it doesn't help that the networking is written in C.
No,
which is
which is generally the disaster language. Yeah. Well, and so is a lot of Linux in general.
Yes, exactly.
Yeah. So yeah, so we have a lot of work. We'll start here because there's a clear value there, and I mean, smart contracts themselves are smaller, and so at this point of the solving this problem space, there's also just like a lot more people and kind of coordination contribution we can get through building applications. But the idea of this model and of the system is to go down the stack. And I mean, that's why I kind of started talking about user-owned internet, because that's kind of what we need to do, right? Like across every stack, leveraging cryptography, leveraging a developer, and rebuilding it in a new way. I think we're approaching the time, or we're already over time. So thanks for tuning in. Hope this was educational. As Alex said, we have not prepared, but we will promise you we will continue not being prepared. But you will actually glean into what we're thinking, discussing kind of day to day, and what we're working on. So tune in for next time. Thank you.